Okay, so for this last video, we are going to review similarity. This is pretty quick, so I just want to go over a few little details of things that are easily forgotten. For number one, it says find the scale factor of the dilated figures below. Okay, remember scale factor. If figures are similar, then you want to have the same scale factor between all the sides. So when you're trying to find scale factor, really if similar figures, dilated figures, doesn't matter. If you look, this 6 is my smallest side, and the other triangle, 2.4, is the smallest side. 13 is the biggest side, 5.2 is the biggest side, and then the 7.5 and the 3 are in the middle. So remember, I always do some sort of system to make it easier to identify sides. The other thing you want to remember is that your scale factor is always going to be, if given, prime over original. Okay, so if you don't have a specified prime, that's fine. Then it doesn't matter, and your scale factor can be like, let's say it was 2, it could be 2 or 1/2. However, in this case, if you notice, these are specified as prime, so we want to pay attention to that. Okay, and then set it up accordingly, meaning we would do 2.4 over 6 and 5.2 over 13 and 3 over 7.5. So you guys, if this were on the final and it was this question and you flipped all those, technically it would be wrong because you aren't doing prime over original. Okay, so if you throw all those in your calculator, you end up with 0.4 equals 0.4 equals 0.4, which is good. That's what you want. So that means that your scale factor, remember that K value that we always look for is 0.4. Okay, or obviously 2/5 would be fine, but it means that this is 2/5 the size of the original. For number 2, we're just talking about similar figures. It says find x in the similar figures below as well as the length of WH. Okay, so you want to pay attention here to angle markings. WC is 4.5. That is across from the angle that is the double angle mark. So then that has to go with 3. Okay, so then this is across from the empty angle, 5x plus 1. So is this. Okay, you can also look at it as like 5x plus 1 goes from 1 tick mark to 2. So does this. However you want to match them up. Now, in order to solve for x, we can set up our proportion. So 4.5 over 3 equals 5x plus 1 over 7x minus 7.4. You guys remember there's many different ways you can set this up. It totally depends on how you look at it. I always have my same triangles. I just like it this way, where these are one triangle and these are another triangle. However, some people like to set it up, like I know if you were in Luber's class, he sets his up so that the triangles go vertical. Like he would do 4.5 over 5x plus 1 equals 3 over 7x minus 4. That's fine too. At the end of the day, you want to make sure when you cross multiply, you're multiplying the same things no matter the setup. So just whatever you're comfortable with is fine. Just make sure that they're consistent. So when you cross multiply this, we have 3 times 5x plus 1 equals 4.5 times 7x minus 7.4. So when you multiply that out, you get 15x plus 5, I'm sorry, plus 3 equals 31.5x minus 33.3. Okay. Go ahead, bring everything to one side. X is on one side, constants on the other. You end up with 36.3 equals 16.5x. Sorry, my handwriting's super atrocious. It's the theme of these videos, apparently. We're going to divide, and x ends up being 2.2. Okay, so that's the first part of the question. It says find x. Then it also says find the length of WH. So WH is 5x plus 1 here. So 5 times 2.2 plus 1. WH ends up being 12 meters when you substitute that in. Okay. All right, so that was quick similar figures. Now we're going to start talking about postulates. So there were, this is determine if the following triangles are similar. If so, state the reason, which is the postulate. why they're similar, as well as a similarity statement. So remember, we had 3 of these. We had side, 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 and angle, angle. Remember, with similarity, sides are proportional and angles are congruent. The biggest thing here, you guys, are remembering back to the quiz and the test. Just because something looks like it should be side, angle, side doesn't mean it is. And just like something could look like side, side, side doesn't mean it is. You have to check that side's being proportional. Okay, so if you look at A, obviously I'm hopefully thinking side, angle, side, right? We have 1 angle pair and then 2 sides. So if you look, this is my biggest side in the first triangle. This is my biggest side over here. This is my smaller side. That's my smaller side. So you want to check and see if 10 over 16 equals 9 over 14.4. Okay, when you put those in your calculator, you get 0.625 equals 0.625. So because they are the exact same, remember, not even like a decimal point difference, they need to be the exact same. Your sides are proportional. So we can say, yes, the triangles are similar. The reason would be side, angle, side similarity. Remember, you guys, that angle needs to be included there. See how it's in the middle of your side? So just remember that. And then we're going to write the similarity statement. So I always start just by writing one triangle. It doesn't matter. So let's say triangle BCE is similar to triangle. Well, BCE needs to be MPD because then they're in the same order. So according to my markings, I went circle, angle, underline. So circle, angle, underline. Okay. In part B, we have 1 angle pair marked, but we can also say, okay, in the middle we have vertical angles here. So then I have no sides, which means side, side, side's totally out of the question. Side, angle, side's totally out of the question. The only one these could be similar by is angle, angle, and they are. Because we have 2 pairs of congruent angles at E and C, and then P and E and C and L. So your similarity statement, again, just write out, doesn't matter, let's say PEN is similar to triangle. P has to go with L, E has to go with C, and N has to go with N. Remember, order is extremely important there. It doesn't matter like what order you put them in, but by order I mean P and L need to be in the same spot, E and C need to be in the same spot, N and N have to be in the same spot. Okay. All right, for the last one on this, hopefully you're thinking side, side, side. No angles are marked, so angle, angle is totally out of the picture, as is side, angle, side. So you have to check your sides. This is my smallest side and my smallest side. This is my biggest side and my biggest side, and then middle and middle. Okay, so it's kind of similar to the first question. You need to check and make sure you have the same scale factor, that your sides are proportional. So 12 over 3, 20 over 5, and 16 over 4. You guys, make sure you're consistent. This, it does matter. You need to make sure this is one triangle and this is from the other triangle. You can't flip-flop, okay? So if you look at that, 12 over 3 is 4, 20 over 5 is 4, as is 16 over 4. So yes, they would be similar by side, side, side because they have the same scale factor. Our similarity statement, let's say triangle A and D is similar to triangle. This is why I use markings. I went from A and then I went circle, underline. So in order to make that happen, circle, underline would be TRE. Okay. Now, you guys, just because it looks it, like I said, doesn't mean it is it. If that had worked out to like 4.1, let's say, then they would be not similar. I don't care what they look like. It needs to all be proportional. Okay. All right, and then the last thing we talked about in this unit were the couple different theorems regarding similar triangles beyond just side, 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 angle, angle, all that stuff. There were 3 of them. The first one was triangle proportionality, meaning if you had parallel lines, if you had a line that was parallel to one side of the triangle, similar to number 4, then it was cutting the sides of the triangle proportionally. Angle bisector, you want to look for bisected angles, okay? That's where we went out and around. And then geometric mean was where you had the 2 right angles, and we had 2 different setups for that, so I'll work through both. So this first one has to be triangle proportionality because of the similar, the parallel lines. So that means that 15 over 4, top over bottom, equals x over 9, top over bottom. So then we can cross multiply, and we end up with 4x equals 135. So x, when you divide, is 33.75 centimeters. Okay. For number 5, that is angle bisector because you have these bisected angles. So that's where we said that x over 12 should be the same as 11.6 over 17.4. So x over 12 equals 11.6 over 17.4. Again, we cross multiply. When you cross multiply, you get 17.4x equals, when you multiply those two together, you get 139. Oops, sorry guys. 139.2. Okay. Divide, and you end up with x is 8, and that is feet. Maybe. Let's try that again. There we go. Well, all right, number 6 is the two right angles, so you should be thinking geometric mean. So we had two formulas here. One was altitude squared equals left times right. Left times right. Jeez Louise, this computer. Okay, left times right. And then the other one was if you had a leg squared equals short times long, or some people said short times whole. Okay, so those were the two formulas that we looked at, kind of depending on what you were given. In this case, we were given a altitude. X is our altitude. So we can do altitude squared, which is x squared, equals left, which is your 12.8, times right, which is your 20. So left to the left of the altitude, right to the right of the altitude. So when you multiply those together, you get x squared equals 256. When you square root both sides, you find that that altitude is a distance of 16 miles. Okay. So that's what it looks like for altitude squared. For number 7, if you notice, you aren't given the altitude at all here, so then you can't use altitude squared. However, you are given the leg. So this is your leg, this is your short, and then you need the whole thing, so you have to add those together for x plus 5, and your setup would be 14 squared equals 5 times x plus 5 for the whole thing. Okay. So 14 squared is 196. Distribute your 5, you get 5x plus 25. So go through, solve for x, you get 171 equals 5x, and when you divide both sides, you get x to be 34.2, and that's in inches. Okay. Okay, this last problem I wanted to bring up, because a lot of people look at number 8 and think triangle proportionality, which is good. You should, because that's what that is when you see the parallel lines. However, if you notice where the x is, triangle proportionality is only talking about the sides of the triangle, whereas x is technically the bottom of the triangle. So you have this top triangle right here, and then you have this bottom triangle right here. Or, I'm sorry, the bigger triangle right there. So we can't say 4.7. A lot of people want to say like 4.7 over x equals 9.4 over 19.2. But then you're not proportional, because then you're saying that the top side of the orange triangle is not equal to the, you're just taking part of the top side of the blue. So when you see this, and when you're solving for that bottom part of the triangle, whereas in number 4, we weren't dealing with the bottoms, it was just the sides, which is why we didn't need to worry about this. You are going to want to look at this as 4.7 over x equals, you want the entire side, so you have to add those together. When you add those together, you get 14.1. So then it would be 14.1 over 19.2. So if you're going to be using the bottoms, you need to look at it more like similar triangles and not triangle proportionality. Okay, so we cross multiply there, we get 90.24 equals 14.1x. you divide, and that X value is 6.4 meters. Now, the only other thing I want to say on that is the other option here, you could use the 5.2 in place of the 4.7. Then you would just need to use this whole side and use 15.6 instead of 14.1. So it doesn't matter which side, it's just the fact that you want to pay attention to, okay, now I'm finding the bottom of the triangle, so it's similar triangles, it is not triangle proportionality. Cool? All right, hopefully that helps. Let us know if you have questions.